Today we have a super special guest, Maxine Levin, who retired 2 years ago from NRCS. She was a national leader of soil interpretation. Has spent like what 4 decades working at NRCS. Has
Yes.
really amazing stories. We know each other for 5 years now, and we met on a conference in Mexico on the Urban Soil Conference, and then we've met many times. So it's really fascinating to know about journey of Maxine and what she has done, not just in the United States, but really all over the world. So she will talk specifically today about soil taxonomy in comparison to world reference based.
I'm presenting a little bit of the work that I've done for the last, probably, I guess, Dr. Petzleva is right, it's at least 40 years, because it started right at the beginning, after I graduated from the university and started working in the field. But basically, I tried to talk, and I made a little comment here, a tale of two systems, WRB and Soil Taxonomy. WRB stands for World Reference Base. And in these two systems, they've sort of grown up together in a bit, in that soil taxonomy was well developed, and then WRB came along and combined many old systems together, mostly from the European viewpoint, but also trying to be worldwide. And both systems are considered worldwide systems. I want to acknowledge a few people just right out of the door. Curtis Monger, National Leader for Standards at USDA, and also the leader of soil taxonomy for the USDA. Peter Schad is the leader in the EU in Munich, Germany for WRB. And then these various other folks who I've visited with over the years have contributed just a little bit to this presentation specifically, but also to some of my background in working with WRB and soil taxonomy. I think I'm going to start out by talking about the role of description as the early step to classification. It's really the whole reason that classification was put together, and it was basically the process of soil description was the basis of also classification. And then that process of figuring out the soil description and doing a good job of doing that, making the location, looking at the soil forming factors, making observations and measurements, and then finally genetic and systematic interpretation, which is the classification. And over the years, there have been sort of defining features for the classification. And it started, and the main thing is worldwide, we were looking for the use of a common language and making it all make sense. The soil taxonomy started very early, but when Europe started to create through FAO, and this is part of the UN, Legends for Soil Mapping throughout the world in the 70s, it became clear that the US taxonomy was focused on the US, and though we were expanding out to other groups, the other countries, mostly in Europe, but also around the world, were starting to build their own maps and using their own taxonomy to build those maps. And we felt that that common language needed to be reoriented. And that was also the beginning of WRB, which was supported, and the WRB is the World Reference Base, which was supported by mostly the EU, but the European countries started it. And what they were trying to do was blend all of their systems together. What ended up happening is that there was a sort of a reckoning. The keys of soil taxonomy, you can see it started really in the 30s, but by 1960, we had what we call the seventh approximation. And in the 1970s, full on, we started to use the soil mapping keys to soil taxonomy to build and rebuild our soil mapping throughout the country. And in 1975 was right about when I came into the system and graduated with my bachelor's degree and started working both in research but also in mapping. And so I was on the front line for using the keys for soil taxonomy in 1983 and working my way through. At that time, WRB was just a glint in people's eyes, not really something that they were even thinking about. And in college, I was taught a soil taxonomy that was basically the Russian system. That was something that was more genetic in purpose and not really the orientation of soil taxonomy. WRB was started in 1992, and the keys for that, for the World Reference Base, the first edition was in 1998, and the third edition was in 2014 and updated in 2015. And with both systems, there was a lot of years where, particularly from about 1980 through the 90s, both systems were in a way developing, ideas. First by the International Soil Classification Management Support Services, which was a USAID supported project, but basically from 1980 through 1990s, there were a series of field tours, worldwide field tours, that looked at all aspects of the different soils and what we could expect. And from that, they were trying to build an international voice where everyone gave input. And just about at the end of 1992, which was when WRB really kicked in, was when the USAID supported system funding ran out, and international work for for soils, for the soil taxonomy ended. And it's an interesting aspect of that sort of dynamic, which is that we, instead of us running the program, and I speak as us as soil taxonomy and USDA, it was more oriented from about early 90s on to WRB in terms of international input. And we were just a participant as opposed to running the show. I'm going to go over just very briefly soil taxonomy. I presume that you all have studied a little bit, and what we're ending up going to do is sort of, I'll show you the differences between them. But basically, soil taxonomy is a quantitative system where we focus on diagnostic surface and subsurface horizons and temperature and moisture regimes. And those are the meat of what soil taxonomy is about. And when we talk about soil morphology, that's, when we go out in the field and we do a pit and we look at the different aspects visually of the soil and take notes, that's for the most part qualitative. And Guy Smith, who was really the original author of the seventh approximation, though it was a large group of people that gave input, and he was the coordinator of that group. He really wanted to make sure that our natural system of soils could be measured, and that any kind of system that described that natural system, it would have to be based on measurements that are aspects of soil morphology that weren't just qualitative, but also measured. And that's how he focused soil taxonomy from the very beginning. And these are just some examples, and I presume with your class you've come across some of these pictures of how you describe soils physically, and it's based on numbers though, and based on measurements, and that's what soil taxonomy was trying to do, was very specifically take those measurements and put them into diagnostic criteria that is described on both the surface and the subsurface. And then also, on the other hand, moisture and temperature regimes were a very important part of the taxonomy and the hierarchy of the system. The 12 orders of soil taxonomy, I've got them listed here. I think these are in, well, they're not in any particular order, except that at times some of these are ones that we see. How much do we see of them in nature? Some of the systems are very small in nature. Some of them you see everywhere in nature. And in the case of entisols and inceptisols, those are soils that you see throughout the world and are represented throughout the world. Some of the others are only in particular parts of the world. The major properties that characterize diagnostic features: on the left, color, amount of clay, base saturation, organic matter percentage, mineralogy, and structure are the basic tools of how we characterize the diagnostic features. And then on the right-hand side, moisture regime and temperature regime are specific to soil taxonomy. Some of the diagnostic surface features, and I don't know if many of you have seen these, but for me, when I see these words, I immediately have a picture in my head of exactly what that looks like in the field and where I would find it in, let's say, the US, somewhere in the US. The word epipedons at the top there is just basically referring to the characteristic place where the surface horizons show these different features. And we often say the diagnostic surface epipedons is what we say, is that combination of horizons. So I'm going to go through them very quickly, but because I presume you've had some of this, but in any case, try to, in your minds, visualize what you're going to try to see and what you expect. So the word molic is thick, dark, high organic matter, black soils, and high in base saturation, meaning that there's a lot of cations in there chugging away and providing nutrients to the system. Umbric is like molic, only it has a lower base saturation, a little bit less cations available for as nutrients. Histic is often at least 12% carbon, and that's plant material that has not been completely disintegrated, and it also depends on clay content. And then melanic is high organic matter, low density, but the key here is volcanic. and then and often it is so light it's almost like dust blowing in the air. And then ochric for a surface is the default epipedon, which is too light in color, too thin, or too low in base saturation to be molic or umbric. So some of the diagnostic subsurface horizons, and this is below the surface and into this, what we call the subsoil. The first one and the most important is the accumulation of clay, the argillic. And it's something that is basic to looking at soils in the field and discerning how much clay has moved in the system. You often see what we call clay skins, where you can see them with a magnifying glass or with your eye. And it's showing the movement of clay and the accumulation of clay in the subsoil. And it kind of discerns also how old that soil might be or how much it's been worked by the climate and moisture. The second one, candic, is low accumulation of low activity clays. And this is one that is where the base saturation is very, very low, extremely low. And you often see this in tropical areas or in the deep south, not necessarily in Louisiana, but it could be in Louisiana. It's more likely to be in Georgia, Mississippi, through there, where you see those low activity clays. And you definitely see those candic horizons as you move farther south, like into Puerto Rico, into the tropics, and down into South America in the tropical areas. The cambic is where there isn't much of movement of clay, but there is change in color, chemistry, or structure. And that's what we call a cambic. It doesn't make the argillic horizon. Natric is high in sodium and a columnar structure. Hopefully these words are familiar to you, as you know, columnar is just how you imagine it, like a column. And the high in sodium, and it creates a particular atmosphere. You almost always just see this in desert areas, but you can see it in areas, at least with low rainfall. And then calcic, an accumulation of calcium carbonate, and that's pretty obvious to see by eye, and that you'll see the calcium carbonate, the white calcium, showing up very clearly in the profile. And then spodic, or some people say spodic. I was brought up to say spodic, but I believe spodic is the correct pronunciation, is alluvial humus and iron and aluminum, and it creates a very distinctive pattern of soils, usually a very black surface, then a white eluviation surface where in the surface or just beginning of the subsoil, where you can you see that all the clay and iron has been stripped out of the system and you're down to silica sand. And then you go into a very dark layer, and this is the spodic layer, which is accumulating organic matter, carbon, or organic humus, and aluminum, and you can see it very distinctly as a bright red or dark layer. And then fragipan is a brittle or dense layer. We often see that in my area of the world, which is the coastal plain of Maryland, and also in California, you see a lot of fragipans. And then as you move north, you might see fragipans, and they're very brittle. I always used to take a piece of the subsoil and put it between my fingers and cushion it and see if it bursts apart. And that's that brittleness I'm looking for, a very dense layer. And then finally, oxic, we never see this too often, but this is a combination of iron oxide, low activity clays, and uniform clay, a lot of clay throughout the system. And you see that mostly only in the tropics. So we don't have it very well defined in soil taxonomy. We've tried to make a good job of it through the 80s and the 90s when we had that all those field tours where we went to a lot of areas of tropical soils. But as I've watched the systems, the WRB is much more specific. The Web Soil Survey is where you see most of this data, and hopefully you'll have a chance in your class here to look at the Web Soil Survey and work with it. This has been my world for most of the time that I worked, was creating these maps. Often there was no information when we went in, not even geology. And we built these maps from this base knowledge base. And the whole purpose of all of these maps is, of course, to make interpretations mostly specifically for use and management. And that is the reason why for moisture and temperature regimes, the soil taxonomy has focused on creating a system that is very specific to mapping and also to use and management. And so when different features were selected, it might not have been, those features might not have been selected as criteria based on how much you saw of them, though it had to be a significant amount for you to describe it that way. But we were thinking specifically about how soils would act and work in a system and whether that could be tested and measured. And that's how the system was put together. And through that, we've made interpretive maps around the world that are really have been valuable. In some of these maps, you see them in all any kind of environmental book or background where worldwide they use these maps in National Geographic to describe specific areas. Now, WRB, the World Reference Base, the general principles are exactly the same or fairly much the same, which is soil properties, measurable and observable, and diagnostic characteristics that define the relationship. But in this way, it's a little bit different in that they really, because they're coming from a European point of view for the most part, and the systems that they worked with, particularly the Russian taxonomic system, were really focused on soil forming processes and what we call genetic diagnostic features. In the end, they have aligned with us very closely, but on some levels, they're completely different. And they leave out moisture and temperature regimes entirely from the system, except in a few cases. They've taken from us the idea that diagnostic features are important for soil management, though, and that was one of the downfalls of many of the European classification systems, is that they didn't use that, but they didn't consider climate factors in the classification of soils. And I have found, working with both systems, that I miss that climatic factor tremendously in the classification and understanding of the soils using the WRB system. But there is potential, and slowly they're adding these types of factors into the soil definitions as they build their system. The reference base is not, at this point, is semi-hierarchical. They say it's not hierarchical in that there's one level only having 32 what we call reference soil groups. And these basically cover the whole world. When thinking about it, they like to say they're very similar to us, and they are. They follow some of the same procedures, in that the step one of using a world reference base is to check and find references to the soil forming factors in the horizon designation. And some of the examples are a dark surface soil and enrichment with organic matter, or a browning or finer texture in the middle part of the horizon in comparison to the parent material. So you're looking for that argillic horizon or some enrichment of clays or irons or weathering. And step 2 is that the profile description and the horizon designation are checked and recorded with expression and thickness of the characteristics and the requirements for diagnostic horizons. And these diagnostic horizons are very similar, if not exactly the same, to the ones that are used in soil classification. And this is one of the points that I've always tried to make in working with both WRB and soil taxonomy, is to focus in on what we have in common and to try to eliminate differences, particularly as it relates to the diagnostic features. How we mix it up afterwards is of interest perhaps only to the person in the field, but those specific broad features, broad terms, morphological characteristics, and analytical data that created the diagnostic features and describe them, that's what's the most important. And if we speak that same language, then we're communicating. The third step is selecting this is with the WRB system, is selecting the reference-based soil group. And here's where, though they say that they need to be systematic, and they're not hierarchical, but in fact, you start at the top of the list and you go down systematically to decide which reference group you're in. And that's how it works. It's the same. It's essentially the same as our hierarchical system. And then they have a second level in World Reference Base where they have the qualifiers for the front and the back of the distinguishing features. And this is where the hierarchy essentially gets to the same place, or very close to the same place, in describing a soil fully. The WRB system, because of their experience, focuses often on more surface features than the soil taxonomy system, but overall they're very close. And it's become, over the years with the World Reference Base, it started out very simple with just 32 separations, but now it's quite complex. And certainly you can describe these soils very specifically with the criteria that's been put together. Over the years, specifically since 2006, we've been doing lots and lots of WRB field correlation tours, sometimes up to 2 a year. And the ones in yellow are ones that I've attended myself. And these field tours have definitely defined the system for the whole world, and have also affected our soil taxonomy system, in that we've seen holes in our system by going and attending these tours, because often we're going to places that have situations of temperature, moisture, combinations of mineralogy and geology that are very, very different than what you might see in the continental USA. And that's where the soil taxonomy system has been the strongest. So the diagnostic horizons aligned between the two systems are aligned, but the climatic factors are not considered except for the wet soils. Aquic means wet in the WRB, and I'm going to show some examples. So I'll go back, first of all, to review the major properties of the diagnostic features, some of the diagnostic surface horizons, and all of these are seen in both the molic, the umbric, the histic, melanic, and ochric are all used in both systems. And then the diagnostic subsurface horizons, again, are used somewhat in all systems with almost the same criteria. So this is a simplified key to the soil orders for soil taxonomy. And Curtis Monger made this for me. And basically it really is the beginning of, the framework for the soil taxonomy. And you can see at the top, actually the first 6 soils, soil orders, gellisols, histosols, spodosols, andisols, oxasols, and vertisols are exactly the same in the WRB system. We see no differences. Let me go through, and there they are there, the gellisols, the histosols, the spodosols, the andisols, oxasols, and vertisols are exactly the same. And I'm going to just quickly go through some of these very quickly. Gellisols, I had the good luck to see some interesting gellisols in Mongolia. And you can see the difference between the two systems. It looks like a lot of words, but basically we compared and we came to almost the same place in both of them. The histosols are based on high organic matter. The spodosols are spodic horizons, and here you can see that spodic horizon and what it looks like. It's very distinctive, and you'll see it all over the world exactly like that. The andisols are andic properties with unique features specifically from volcanic ash, and once again they're distinctive from the rest of the world, but they're very similar to each other around the world. And where you see them is basically in volcanic areas. So the West Coast, you would not see them in Louisiana. You're going to have to go to the upper Northwest to really see those andisols in the US. Oxasols, once again, we won't see them in the US. We might see them a little bit in Puerto Rico, but that's all. And but where they are in South America, of course, and in Africa. We see them a lot, and in some parts of Southeast Asia. And there you see it. It's a bright red soil, very well drained. And what's happening is water's flowing through it all the time. And it creates a soil that has, the clay particles are highly low base sat, extremely low base sat. And the particles are sort of accumulated and grouped together in a very loose manner, where it almost looks like sand particles, but they're actually clay particles when you look at them under a microscope. Vertisols, once again, they're all over the world, but they're very distinctive. These are the high shrink swell clays. And I had the opportunity to see one in Mongolia, and you can see that cracking on the surface, and it's distinctive and visible in every soil, whether you're in Texas or whether you're in Mongolia. You'll see the same soil. Now the other ones, the aeritic, the soils in the next categories are classified completely, not completely different, but the systems are completely different in how they work out. And the first one, the aridisol, is based on an argillic horizon and anaridic moisture regime. So when you think about deserts, it's got to be the desert that has the clay in it, not the sandy dunes. Those are entisols. And the iridosols are all over the world. And with an argillic horizon that's usually, this slide is out of place. This is really a different soil. This is the, this is to do with ultisol. So we'll have to move that slide for you for the final grouping. But here with an argisol, iridosol, you can see this, in this case, a calcic horizon, but with the WRB system, they focus in on all the different kinds of materials that might, whether there's calcium or not in the system. So they end up with many different versions in the system, whereas we look at those as extra parts. And that what's most important is that there's an accumulation of clay and that there's an anaridic moisture and temperature regimes and thermic temperature regimes. If we go farther down here, the molic horizon, the mollisol, is something that we see all over the world, but it's looked at just a little bit different with the European WRB system, in that they separate out mollisols much more distinctly into many different categories. And that's partially because of the Russian system, where mollisols were so important to the Russian system that they had to keep all those distinctions very separate. And you can see them around the world, and you can see where the mollisols are in the world, in our Midwest, but throughout Russia, through that mid part of Russia. And I think, Dr. Patsleva, you grew up in mollisols, didn't you? So if you go farther down the key, the next grouping is the argillic horizon, at the emphasis of argillic horizon, and whether with the base sat you see a ultisol or an alphasol. And it's all about the base sat. Less than 35% in the subsoil, it's an ultisol, meaning a very old, much older soil that has been washed through with all the bases, and less than 35%, greater than 35% base saturation for an alphasol, where the base cations are still accumulating in the system. And so the alphasols are in one range, and the ultisols are farther south. And as you see in Louisiana, in the uplands, you can see a lot more ultisols than you'd see in other places. And then finally, cambic horizon is that neutral kind of inceptisol. Inceptisol, I think of it as a teenager. And WRB looks at it somewhat the same, but has many different pieces. And then finally, entisols with no diagnostic horizons. So one of the things that I would encourage Dr. Patsleva to do is to take you all on a tour of the US. And we don't really have enough time to do it right now, though I would love to take you on a tour of the US. And basically we would fly to Alaska, and what would we see there? We'd see gellisols. If we went down the coast, what would we see? Down to Washington State around Mount St. Helens, we'd see that ash, and we'd see andisols. We'd then drive to the Delta around San Francisco, and we'd see histosols. We'd drive across the Sierras and to see Half Dome, let's go back, to see Half Dome, and take lunch at the river at the saline sand dunes. And what would we see? We would see entisols. We'd drive south to Arizona, in Nevada, and we'd see the aridosols, the soils with argillic horizons, but in the deserts. Then we'd go Nebraska to the cornfields, and what would we see? The mollisols. And then we take clay plains outside of Houston, we'd see vertisols. We'd drive southeast and we'd see those ultisols, and eventually driving north to the alphasols of the Piedmont of Vermont, the Piedmont of Virginia, and then finally far north, we'd either have to choose to go far north or far south, and we'd see those spotted horizons. It's kind of fun just to think of it that way and think it visually of all the different soils you could see, and through the taxonomy system, you can visualize them in your head. So finally, a little summary and highlights. The comparison, I tried to do a little comparison of WRB and soil taxonomy. Both are focusing on use and management, or at least attempting to. They're both evolving to hierarchical systems where you have to go down a key, and both should be aligned with the diagnostic properties. What's the real take home for you all is both of these systems are keys. So you don't have to memorize the key. The most important part is to really visualize and know the diagnostic properties and know how to identify them in the field. And from that, you can move on to being a real expert in taxonomy and being able to describe and communicate soils to the rest of the group.